Hi, in this video we will learn what is an eigenvalue and corresponding eigenvector for a square matrix. Let us start with the definition and then we will do some examples. First of all, eigenvalues and eigenvectors are defined for square matrices. So let A be an n by n matrix. Then an eigenvalue of A is a scalar, a number. A scalar lambda is an eigenvalue. So eigenvalue is a scalar, it's a number of A if this happens that we can find a non-zero vector, if there exists a non-zero vector v such that, well, we are assuming that v is n by 1 matrix vector, it's a column vector, then you can multiply a to v. And it will give you another vector, which will be again a column vector. We want that AV, which is a vector, to be just a multiple of V. In other words, A multiplication of A to V is nothing but just multiplying by lambda in the direction of V. Well, in that case, we call V an eigenvector. So this is a vector, eigenvalue is a number of A, well, corresponding to the eigenvalue lambda. So we have to see if we can find a non-zero vector. It is very important. Eigenvectors are non-zero vectors. Zero vector is never an eigenvector. Okay? But for different eigenvalues, we may find different eigenvectors. Let's see some examples here. Yeah, okay. So in this given examples, try to show that what given vector v is an eigenvector of the given vector A, the given matrix A, and then what is the eigenvalue of that eigenvector. So what we need to do, we need to show that A times V is a multiple of V. Well, let's do that then. 1, 2, negative 2, 5 times 1, 1. This will give us 1 plus 2, negative 2 plus 5. And this is 3, 3. You see, this is AV. We have to show that it's a scalar multiple of V itself. And you can see that by just seeing this fact that it is 3 times V itself. In other words, what we showed is that AV is 3V. So that means that, yes, this is an eigenvector of A corresponding to eigenvalue 3. So that's what we have. How about this one? Okay, again, you multiply the matrix 1, 2, 1, 6, negative 1, 0, negative 1, negative 2, negative 1 to the vector negative 1, 2, 1. What do we get? We get negative 1 plus 4 plus 1. negative 6 minus 2 plus 0, and then 1 minus 4 minus 1. And well, this is just 4, negative 8, and negative 4, yes. And as you can see, well, here I have to show that this is a scalar multiple of the vector we started with. So negative 1, 2, and 1. And as you can see, yes, it is basically this guy, the same vector v multiplied by negative 4. In other words, what we showed was that AV is negative 4v. That means that yes, this is an eigenvector of A corresponding to eigenvalue negative 4. The multiple you see there, it is the eigenvalue. Okay, so this example, the other example, says that show that the given lambda is an eigenvalue of the given matrix. So what should we do? We should show that we need to show that there exists a non-zero vector such that AV is equal to 4V. Well, this is a linear equation and we are trying to find V. Well, you would say there are two V's there. Well, what I can do here is that I can see this 4V, 4V as 4 times identity matrix to V. And you know, identity matrix to any matrix or vector that you can multiply to, it gives you back the same vector or matrix. So this means that we have 4 identity minus A times vector V is equal to 0. So this means it is equivalent to show that A of 4 identity minus A times V is equal to 0 has a non-trivial solution. It has no non-trivial solution. What do we need to do here? Well, find 4 times identity matrix. Here is it, this one, minus the matrix A. This gives us what? This gives us 4 minus 6 is negative 2. This is 1. This is 2. And that is 4 minus 3. It is 1. Just a second. Okay, this is negative 2. Sorry. 0 minus 2 is negative 2. Okay. So what we need to show is that this system has non-trivial solution. Or in other words, the augmented matrix has non-trivial solution. And that's easy. Just R1, R2 minus R1 would give us 0, 0, negative 2, 1, and 0, 0. From there, you can see that x, negative 2x plus y needs to be equal to 0, and y needs to be our free variable t. I'm just solving this system, yes? And then, when you solve that, you see that, the solutions will be of the form minus t over plus t over 2 and 1. Well, t, sorry, this is t. Or in other words, any multiple of half and 1 would do the job for you. Okay? Well, let's just take t to be any non-zero. So half and 2 is an eigenvector of A, corresponding to lambda equal to 4. Well, you can check it again, but what we did here is that finding such v, we turned it into a system of linear equations, and then we solved it and we found a non-trivial solution. That non-trivial solution is going to be a non-trivial, an eigenvector of the matrix. How about this one? Okay, very nicely. This time we will do I times identity matrix. So I times identity matrix minus the matrix A, and make this guy augmented. We have to find a non-trivial solution for this. This is indeed is equal to I 1 negative 1 and I. Here, this is 0, 0. We want to solve this one. Okay, if we multiply row 1 by another I, it will give us I times I is negative 1. Then subtract that from R2. This will give us I times I is negative 1 minus, so negative 1 minus negative 1 is 0. And 1 times negative I plus I is 0. And this is I1. We'll find now a solution for this. This means that I times x plus y is equal to 0 and y is equal to t. And solutions for this will be t 1 over I and t. Well, you remember that 1 over I, what is the inverse of identity? Is sorry, not identity, the imaginary number I. It is negative I times t and t itself. So I can factor that out, and that is what we have. So for all non-zero t, these guys are going to be eigenvectors of this matrix corresponding to eigenvalue I. And in particular, you guys just take t to be 1. This is an eigenvector of matrix 0, negative 1, 1, 0, corresponding to eigenvalue I. As I said, you can put any t here, non-zero t, that will give you an eigenvector. Oh, the same old thing. So here I have lambda just 3, 0, 0, 3, 3 times I minus 2, 0, 4, 3. Everything is happening in Z2, so this will be 1, this is 0, this will be what? 0 minus 4 is 1, and here we have a 0, 3 minus 3, this is 0. And yes, we have to solve this solution that we have here, the system that we have here, homogeneous. Again, you can do simple R1 plus 4, R2 plus 4 R1. That will give you 0, 0, 0 here. And that means that x is equal to 0, y is equal to any, this is a free variable. So this means that 0t for any t in Z5 is a solution, non-zero solution for that. In particular, you can take this guy to be your eigenvector. So 0, let t be equal to 1. 0, 1 is an eigenvector of 2, 0, 4, 3 corresponding to lambda equals to 3. So the definition of eigenvalue, eigenvector, you have to know, and you have to be able to compute one if you know the other one. Well, we will learn more things how we can compute both of them if just we know the matrix itself.